In Chapter 2, Section 6, we're going to prove angle pair relationships. Now, we learned these angle pairs in Chapter 1. Now, today, we're going to prove what we learned about them in Chapter 1. So, how are we going to prove it? Now, we're not going to prove it using flowcharts or paragraph proofs, but we do want you to know that they are valid methods of proving things. The flowchart or flow proof uses boxes and arrows to show the flow of a logical argument. A paragraph proof presents the statements as reasons of a proof as sentences in a paragraph. And so we're going to show you what they look like so that you can recognize them. However, we're not going to be using them ourselves in our class. So the first theorem we're going to talk about is in this section, obviously, is 2,3. Again, the number's not really important. It's the theorem that says it's right angles congruence theorem. And the right angles congruence theorem tells you that all right angles are congruent. So that means that this theorem is saying that all right angles are of the same size and the same shape. So now, in a flowchart proof, we're going to give you an example of how we might prove that all right angles are actually congruent. So notice in this drawing, we've got it says the given angle 1 and angle 2 are right angles, and you can see that in the picture. Prove that angle 1 is congruent to angle 2. So they're both right angles. You have to prove that they're congruent to each other. Same size, same shape. So the flowchart proof, notice that it starts with the given. It says in the little bubbles, right, or the boxes, angle 1 and angle 2 are right angles. Again, that was given to us, and so they describe the reason underneath it. Then that goes to the next statement, which says that angle 1 equals 90 degrees and the measure of angle 2 equals 90 degrees. Well, again, you have to think about that. If you know that two things are right angles, you know that they equal 90 degrees. But how is it that you know that? Well, you know that because you know the definition of a right angle. A definition of a right angle states that a right angle has a measure of 90 degrees. So, then from there, they go to the measure of angle 1 equals the measure of angle 2. And they state that that was the transitive property that allowed them to do that. And if you go back and you change the order a little bit of this previous statement, if you say something like the measure of angle 1 equals 90 and 90 equals the measure of angle 2, then the measure of angle 1 is equal to the measure of angle 2 rather, and basically you cancel out the 90s. Now the order isn't exactly perfect for a transitive property statement. I would have written it in a different order, but again, it's still the transitive property that allows you to do that. And then the last step is, notice you're going from the measure of angle 1 equals the measure of angle 2 to the measure of angle 1 is congruent to the measure of angle 2. And that's definition of congruent angles. Now this definition here of congruent angles basically allows you to convert things that are equal to make them congruent, or things that are congruent to things that are equal. It allows you to go back and forth, because what the definition says basically is that if two angles or segments are congruent, then they are equal in value. And if they are equal in value, then they are congruent. And so anytime you're going to swap or change from equal to congruent or back, you can use the definition of congruent angles or segments to do that. Now we're going to take that same right angle congruence and that same angle 1 and angle 2, and we're going to put it the same things in our statements and reasons in our 2-column proof. So again, angle 1 and angle 2 are equal. That was our given. The measure of angle 1 is 90. Measure of angle 2 is 90. That's definition of right angles, right, or of a right angle. Again, angle 1 to angle 2, that was where we did transitive. Now, I will be honest with you. If I was going to do this as transitive, I might have written B as measure of angle 1 equals 90, and 90 equals the measure of angle 2. And therefore, the transitive property allows us to make this choice here. Okay, so yes, it was transitive the way they did it, but I would have written it in a different order because I think it would have made more sense. And in fact, I might have not even used transitive at all. if I'm being completely honest with you, in this statement here, notice that we said that the measure of angle 2 was equal to 90 degrees, which means now I can substitute 90 in for the measure of angle 2 anytime I want, or the measure of angle 2 for 90 degrees anytime I want. Once I state that things are equal, I can substitute. And so really, all I'm really doing from here to here is substitution. So that would have been another way to do this. And this is why I tell you that we might have different proofs and different steps, but if they're logically valid, they're okay. So I probably wouldn't have even used transitive, and I would have just done substitution myself. Either one is correct. And then notice that we go from the measures of 1 equaling the measure of 2 to stating that the angles are congruent to each other. And notice all we did was we went from the measure being equal to the angles being congruent, and that's definition of congruent. And then it's whatever we're talking about. In this case, we're talking about angles, so it's definition of congruent angles. Now, what's really nice is now we have just proven the right angle congruence theorem. So in the future, if you get something where you're given that the two angles are right angles, you can now conclude, you can go straight to the conclusion that the angle 1 is congruent to angle 2 because we've already proven it. You don't have to show all these steps in the future. So again, if you're given A, you can conclude D, and you can conclude it because of the right angle congruence theorem. That would be your explanation for why you can go from A to D without anything else. So it's nice. Once we prove things, we don't have to give you all those middle steps every time we're going to use the theorem. Now we're going to go to another theorem that we're going to learn now, which is congruent supplements theorem. Okay, the congruent supplements theorem says that if two angles are supplements to the same angle or to congruent angles, meaning angles of the same size, then they are congruent. So if you look at this picture, what it's saying is that if angle 1 and 2 are supplementary if angle 1 and 2 are supplementary and 3 and 2 are supplementary, then 1 and 3 are congruent. So let's just think about it using numbers. Let's reason this out to make sure we understand it. Let's pretend that angle 1 has a measure of 10 degrees. If it's supplementary to angle 2, then angle 2 has to equal 170 degrees because we know that supplements have a sum of 180, right? And notice that if angle 2 has a sum equals 170, if it's supplementary to 3, then 3 also has to be 10 degrees because 2 and 3 have to add up to 180. So notice that 1 and 3 are both supplementary to 2, and that makes 1 and 3 equal to each other. So yes, the congruent supplements theorem makes sense, and yes, it's true. Now, in the next slide, we're going to prove this theorem to be true. So again, here we're proving the congruent supplements theorem. And if you notice, when you go to number 1, it gives you the given from the top. The given up here is that angles 1 and 2 are supplements, and 3 and 2 are supplements. And so my first reason is given. And remember, always do the given. This is your freebie. Number 2 says that the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and the measure of angle 3 plus the measure of angle 2 also equals 180 degrees. So what they did was they went from knowing they were supplements to converting that to mean that their sum is 180. How did they know that supplementary angles have a sum of 180? Well, that was a definition of supplementary angles. We learned that in chapter 1. Supplementary angles. Okay, so again, things we learn in previous chapters, we're going to need to retain and remember, especially the things we learn in these first few chapters. They're going to come back throughout the entire book, okay? So notice from step 2 to step 3 now, what they did was they had the measure of angle 1 plus measure of angle 2, and instead of equals 180, they had it equals this down here, measure of angle 3 plus the measure of angle 4. And so what you notice they did was they used the substitution property of equality. Because they introduced here in step 2 that angle 3 plus angle 2 equals 180, or the sum of it equals 180, then we can swap out the sum expression for 180. So they use substitution. Again, we go from angle 3. Remember, we're trying to prove that the angles are congruent. So we want 1, we want 3, we don't want angle 2 listed in there. So how did they get rid of angle 2 from both sides? And if you notice, what they did was what we talked about a few days ago, was the subtraction property of equality. They subtracted the measure of angle 2 out from both sides. Now that left them with a statement saying that the angle 1, the measure, is equal to angle 3, but notice they want congruence. And so anytime you're going to go from equal to congruent, you're using the definition of congruent. And again, because this is angles, it's congruent angles. So again, when you're switching from equal to congruent, you use the definition. When you go from congruent to equal, you use the definition again. Now, what's great about this is, again, in the future, when I tell you that two pairs of angles are supplements to the same angle, you can just conclude then, because of the congruent supplements theorem, that angle 1 and angle 3 are congruent to each other. You don't have to give me all these steps in a subsequent proof to prove that, okay? You can go from step 1 straight to step 5 if you're trying to prove something else using this, okay? Once we prove it, then you can use the theorem in a subsequent problem as one of your reasons, okay? When we go to 2.5, we get to congruent complements theorem. And again, this is the same concept or same idea as congruent supplements theorem. If two angles are complements to the same angle or congruent angles, then they are congruent. So again, the only difference here is that the angles are complements. And again, definition of complementary angles says that the sum of complementary angles is 90 degrees. So this definition would probably come into play if you were trying to prove this one. We would basically do all the same things we did in the other slide, except we would make them equal to 90, as we'd say they're complementary, and then we'd make them equal to 90 as opposed to 180. A postulate that we're going to talk about here is a linear pair postulate. So again, a linear pair postulate tells you that if two angles form a linear pair, then they are supplementary. So the linear pair postulate tells you that a linear pair is supplementary. Okay, so a few things come into play here. First of all, when you look at this diagram, you notice this diagram and you conclude that angles 1 and 2 form a linear pair. How do you know they form a linear pair? Well, that would come from the definition of a linear pair in the first place, okay? The definition of a linear pair tells you that they share a vertex, they share a side, and the other side are opposite rays of each other. So the actual definition of a linear pair doesn't mention supplementary and doesn't mention that they add up to 180 or anything else. It just tells you what it looks like. So the second thing says angles 1 and 2 are supplementary. How do you know that? How do you know that angles 1 and 2 are supplementary? Well, you know that because this linear pair postulate, okay, this linear pair postulate tells you that if two angles form a linear pair, which they do, then they must be supplementary. Okay, and then we go from that to the third thing that says, well, then angles 1 and 2 must add up to 180. This is where you're changing and saying, well, if they're supplementary, their sum is 180. And this is coming from definition of supplementary angles, because that's what tells you that the sum is 180 degrees. Whoops. So notice three different things. Like when I look at this picture and I see this, I know that 1 and 2 add up to 180 degrees, but basically my mind took me to 3 steps of logic. I know, number 1, that they form a linear pair because I know the definition of a linear pair. I know that a linear pair is supplementary because of the linear pair postulate. And I know that supplementary angles add up to 180 because the definition of supplementary angles. So these are three things that you might have not thought of, but that's what went into your thinking to know they added up to 180. That's the purpose of a proof, is to write out everything that proves what you're thinking. Now we go to vertical angles. So now we have a vertical angles definition. So first of all, definitions usually help you identify what you're looking at, okay? Usually used to identify things, okay? So in other words, the definition is going to help me to identify a vertical angle. So the definition says two angles such that the sides of one angle are opposite rays to the sides of another. Okay, so in other words, the side of angle 1 here is an opposite ray to the side of angle 3. Same with this one. Okay, and so that's where we get to identify that 1 and 3 are vertical angles and 2 and 4. So again, the definition helps us to identify them. Now we're going to use a vertical angles congruence theorem. This is where this theorem here tells you that vertical angles, once you've identified them, right, are congruent. Okay, so it tells you they have the same size and shape. So this theorem is what tells us that angle 1 equals angle 3 and angle 2 equals angle 4. So the definition helps us identify which angles here are vertical angles, and the congruence theorem tells us that they're equal once I identify them. So again, here's a paragraph proof proving that vertical angles, or proving the vertical angles congruence theorem. So they're giving us in this picture, angle 5 and angle 7 are vertical angles, and we want you to prove that angle 5 and angle 7 are congruent. Now, I know this theorem tells us they are, but we have to prove the theorem, and if we have to prove it, we can't use the theorem in its proof. We have to use things we learned before that show us that those angles are actually congruent to each other. So notice in the paragraph proof, the first thing they list is 5 and 7 are vertical angles formed by intersecting lines. Basically, they're saying that 5 and 7 are vertical angles. That's given. Okay? As shown in the diagram, right? Then here, 5 and 6 are a linear pair, and 6 and 7 are a linear pair. So again, now we're changing the fact that 5 and 6 form a linear pair, as do 6 and 7. So again, how do I know that those two angles form a linear pair? Well, because I know the definition of a linear pair, right? In the third thing, using the linear pair postulate, I know that 5 and 6 are supplementary and 6 and 7 are supplementary. Again, if I know that angle 5 and angle 6 form a linear pair, then the linear pair postulate tells me that they're supplementary, right? And again, if I know that both of these are supplementary to the same angle 6, that same other side, I know that 5 and 7 must be congruent to each other because of the congruent supplements theorem, which I already proved in a previous slide. So in a paragraph, I find it a bit confusing, but it basically walks you through the thinking. Again, we're going to do it as a 2-column proof, same scenario, okay? So again here, 5 and 7 are vertical angles. That was given. Okay, 5 and 6 are linear pairs, and 6 and 7 are linear pairs. Well, again, we look at the picture and we're able to identify that they're linear pairs because we know the definition of linear pairs, right? The definition gives us what we need to identify the linear pairs in this picture, okay? When I go from 2 to 3, we're saying that linear pairs are supplementary. Well, again, we learned in the linear pair postulate, we learned that linear pairs were supplementary. So that's why we can go from 2 to 3. And now, again, notice that we're told they're supplementary, and now we're told that if they're both supplementary to 5 and 6, then they must be equal to each other. Now, that required a proof a few slides back. We had to prove that supplementary angles added up to 180, and then we subtracted out what would have been like an angle 6, and it would have left us with 5 and 7. But we don't have to prove that anymore because we already proved it. So once we know that 5 and 7 are both supplementary to angle 6 in step 3, then we can say that 5 and 7 are congruent using the postulate, the congruent supplements theorem. And again, we got to get these names right? Congruent supplements theorem. So we know we don't have to prove the in-between steps between 3 and 4 that we proved a few slides back. Now, how are we going to apply those things to a problem like this? Well, if I gave you a problem like this on a math test, and I believe I did in chapter 1, you would look and say, oh, these are vertical angles. Vertical angles are equal. So you would set it up and you would actually, subtract 1, divide by 3, and you would get x is 49, and that's the answer. However, I want to break this down a little bit to all the reasons why we knew how to do that. And this, okay? So I want to think of it more as a proof, even though you weren't asked to prove this. But for example, when I look at this, I see that angle QPR here, angle QPR and angle TPS are vertical angles, okay? I know they're vertical angles because of the definition of vertical angles. That's what helped me to recognize that they were vertical angles. Then, if they're vertical angles, I know that angle QPR is going to be congruent to angle TPS. How do I know they're congruent? Because of the vertical angles congruence theorem. That tells me that vertical angles are congruent. Okay? And if I know that they're congruent, I know that the measure of angle QPR is going to equal the measure of angle TPS. I know that because of the definition of congruent angles. Okay? And then if I know their measures are the same, then I know that I can substitute their expressions for the measures, right? Because I know that angle QPR equals 3x plus 1. I know that angle TPS equals 148. And so I can sub it into this problem that 3x plus 1 must equal 148. Then I'm going to subtract 1 from both sides, leaving me with 147. Well, guess what? That's the subtraction property of equality. This one here, up here, that would have been substitution. And then here I would have gotten x is 49, and that would have been the division property of equality. So again, when you solve this on the last assessment and you did these 3 steps, this was really all the thinking behind the scenes as to why you did what you did and why you could do what you did. But if I ask it to you in a proof, you just have to walk me through it. How did you know they're vertical? What does it mean that they're vertical, right? And if they are congruent, if that's what it means, then does that mean that they're equal? How do I know that congruent means equal? And again, how do we go about solving this? So all these steps are involved. Again, here we're going to do some true-false statements, and then we're going to finish these slides. First, it says the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Then angles A, B, and C are supplementary. This is false, okay? Because the definition of supplementary angles is 2 angles whose sum is 180. It's 2 angles. It can't be 3 or more, okay? Number 2, vertical angles have the same measure. True, okay? And the last one says if angles 1 and 2 are vertical angles, and the measure of 1 is 2x plus 8, and the measure of 2 is 3x plus 4, then x is 14. Is that true or false? You have to draw this out, right? That's just exhausting to even try to read, right? So here's angle 1, here's angle 2. they're telling me that they're vertical, so I drew it out. Angle 1 is 2x plus 8. Angle 2 is 3x plus 4. So the setup for this, obviously, if they're vertical angles, 2x plus 8 would equal 3x plus 4. So now we have to solve for x. So I'll subtract 3x from both sides. Minus x plus 8 equals 4. I'll subtract 8 from both sides. I'll get minus x equals minus 4, and I'll get that x equals 4. And so x does not equal 14. So this is false. Okay, it does not equal 14. It equals 4. And so, again, these are some types of questions that we're going to ask you, but these questions are applying some of the things and definitions and things that we used in this section. So at some point, I highly recommend that you write down, obviously, like I did in class, definitions and postulates and theorems, things that all go together. For example, you know, when you're talking about congruent supplements theorem, you know that definition of supplementary angles might be a definition that you might use along with it. Or vertical angles theorem, you know that you might need to know the definition of vertical angles. When it comes to linear pairs, you might need to know the definition of a linear pair, definition of supplementary angles, the linear pair postulate. There's a lot you might have to know. So again, you might want to write down all these things, but kind of tie them together as to which ones sort of go with which. You will really begin to see the pattern as you do more and more proofs. It will get easier, but it won't get easier without you kind of memorizing these things. So have some flashcards or something at your disposal when you're doing the work that you can refer back to help guide you.